Okay, everybody. Assalamu alaikum. So today we are going to first of all cover up solubility rules, okay, and then we are going to talk about the equation balancing, and then we'll talk about the Ionic equation. Okay. Anyways, so this is the solubility rules. Okay. So the very first solubility rule that you have is that all metals are solid except mercury, which is in the liquid state. Okay. Then all compounds are soluble that have span 1 in it. Span 1 means that it has sodium ion, potassium ion, ammonium ion, nitrate ion, and group 1 in it. Okay. Please note that in the test, for example, you had sodium, okay, and it had to be in the solid state. Why? Because this metal is not in the ionized version, okay, because of which you'll say that this metal is in the solid state, okay. Let's say if this metal was ionized, okay, then you would have written aqueous in it. Are you getting? Okay. Anyways, then coming up over here, insoluble are silly halide. Okay, so that means if you look over here, okay, you have sodium fluoride, silver bromide, rubidium acetate, then lead bromide. Okay, now look over here. This is fluoride over here. It's group 7. Okay, and it has group 1 metal attached to it. So it is soluble. This halide, okay, this is a halide because it has group 7 element in it and it has silver attached to it, so it will be insoluble. Why insoluble? Because it's a silly halide. Okay, then this one over here is soluble. Okay, why? Because this one is group 1 and this is also not a silly halide. This one, lead bromide, this is insoluble. Why it is insoluble? Because it's a silly halide. Got it? Okay. Oh, this rule had to go over here. Anyways, so then we have, okay, so what is the first rule? First rule is all compounds are soluble that have span 1. The second rule is insoluble is silly halide. Okay. The third rule is insoluble are all carbonates except SPA1. By SPA1, we mean sodium ion, potassium ion, ammonium ion, and group 1. Okay. So when we look over here at the carbonates, okay, we have two carbonates over here, sodium carbonate and calcium carbonate. The sodium carbonate is soluble. Why? Because it's of group 1, right? Okay, so it has to be soluble. Calcium carbonate, okay, is insoluble. Why? Because it is not SPA1, right? It's a carbonate, and to carbonate, it's calcium, not a SPA1, right? Okay. Then the third rule is all hydroxide except SPAC1 are insoluble. That means if any hydroxide has sodium, potassium, ammonium, calcium ion, or group 1 in it, so it is going to be for sure soluble. Otherwise, rest of them are going to be insoluble. Also, you have to note over here that calcium ion is sparingly soluble. By sparingly soluble, we mean this is R over here, okay? Sparingly soluble means that it is barely soluble. So you have to stir it a lot. Okay, so if you look over here, calcium hydroxide, what is this? It is soluble. Okay, and when we talk about magnesium hydroxide, this is what? It is insoluble. Why? Because it doesn't have a SPAC 1 in it, right? Then we have all sulfates. Okay, sulfate block is insoluble. Block stands for barium, lead, and calcium. Okay, so look over here. Magnesium sulfate, soluble. Why soluble? Because it is not sulfate block. Barium sulfate, insoluble. It's sulfate block, right? The B of block is here, barium is here. Then calcium sulfate is insoluble. Why? Because it has C of block in it. Okay. Potassium sulfate, it is soluble because it is not sulfate block and also it has group 1 metal in it. Got it? Okay. Now we are talking about the basic chemical equation first of all that we learned in the class. Okay. So we learned that acids when it reacts with Either if it reacts with metal, okay, so it forms salt and hydrogen. And if you remember, we have to remember it from the keyword mash, right? Acid is metal is mash, right? Okay, so if an acid is reacting with a metal, it will produce salt and hydrogen gas. If acid is reacting with metal oxide, it will form salt and water. Then, if you look over here carefully, all three of them are having the same byproduct and the common and the main product. Okay, so along with the salts, all of them are releasing water. Only the metal is releasing hydrogen gas, right? Then, if you look carefully, since it has carbon in it, so carbon dioxide gas would be produced. Got it? Okay. Now we are doing the basic chemical equations. These two I've done already with I've done already for you. Okay, so I'll just quickly go through it. Okay, look. This one is, in fact, let me do a new one. Okay. So these are already done with for you. You can have a look over here. You can have a look over here. Okay. And you can have a look over here. And let me do the other one for you. The fourth one. Okay. That is ammonium hydroxide if it reacts with HCl. Okay, if ammonium hydroxide reacts with HCl, that means acid is reacting with hydroxide. Always a water would be formed for sure, right? Then, along with the water, what will we get? We will have ammonium ion combined up with chloride ion. One, cross it up. One will be written and it will be NH4Cl written over here. Got it? Then over here, hydroxide. It is having ammonium ion in it, for sure soluble. So we will write aqueous over here. All acids are aqueous, so we will write aqueous over here. Ammonium again in it, for sure soluble aqueous over here. Water is liquid, for sure liquid over here. Right. Then we'll see if it's well balanced or not. Ammonium 1, ammonium 1. O1, O1, HR2, 2, and then we have Cl1, 1. This was very easy to check if it's balanced or not. I would highly recommend it. The way, we talked like that to split up in the class and then do it like that. For this equation, since it's really balanced, I'm not doing, but for other equation that I'll do for you, I'll balance it out for you. Okay. Anyways, so now look over here. Ammonium is aqueous over here. Ammonium is aqueous over here. So cut out. Hydroxide aqueous. Hydroxide water liquid. Not cut out. Hydrogen aqueous. Hydrogen liquid or this not cut out. Then chloride ions over here. This is aqueous. This is aqueous. This is cut out. Now remember, we only split up the compounds which we have cut out. Okay, this water, since it is not split up, we are not cutting it out. In fact, why should I even split it? Because this is already cut out, the whole thing. The whole thing is cut out already, right? So I'm not even investing my energy to cut out because I'm not even going to mention it in my ionic equation. Okay, so if I split up, it would be like this: OH positive, this is negative, this is H positive, this is Cl negative, Cl cut out, ammonium cut out. Then we'll write OH negative over here. Aqueous would be copied over here. Then we have hydrogen ion over here. Then we have aqueous over here. And then we have water over here in the liquid state. So it would be written like that. Got it, everybody? It is balanced and it is written balanced. Okay. Then we have um, this this one I'm not doing, okay, because what you're going to do is very easy. You're going to just write aqueous over here. Okay, this is acid, and over here this is ammonia, this is gas, okay, and this is aqueous, and then you're going to cut out after balancing it. So I'm not going to do this one. This one is pretty easy. You do it on your own and then check it with the uploaded notebook which I've uploaded in the Google Classroom. Now let's do this one. Okay, Lead nitrate, lithium chloride, forming this and this. Okay, can we solve it over here? Never mind. We'll take it down there. So it is lead nitrate reacting with lithium chloride. They won't ask you to form this chemical equation because this is what you learn in class 10. So maybe just equation balancing can come like that. Okay. Anyways, so over here, now look, if I want these two to pair up, okay, so how would I write? I would write like this, that Pb positive 2, okay, and Cl negative 1. So 2 goes here, 1 goes here, and this is PbCl2, right? And then this is lithium and this is nitrate. So I will not write over here like this. I will not write over here right like this. Okay, I will first of all do my rough work. Lithium 1 positive and nitrate is negative 1. 1 goes here, 1 goes here. So it is LiNO3 over here. Now we'll copy the state symbols over here. Okay, you see this one. Now we'll write the state symbols over here. Nitrate ion is here for sure, aqueous. Lithium chloride, not a silly halide, aqueous over here. Chloride, but it has lead to it. It is a silly halide, solid. Nitrate, it has also group 1 element in it, for sure, aqueous. Okay, now let's balance it. We'll write lead over here, then we'll write nitrogen over here, oxygen over here, lithium over here, and then chlorine over here, and then we'll copy as it is this whole thing over here. Lead is 1, nitrogen is 2, oxygen is 6, lithium is 1, chloride is 1, lead is 1, chloride is 2, lithium 1, nitrogen 1, oxygen 3. When I was writing this 3 over here, I can clearly see this, that this is 6 over here and this is 3 over here. So I'll just write 2 over here. And when I write 2 over here, so what will happen? This will turn up into 2. This nitrogen will turn up into 2. And this oxygen will turn up into 6. This is balanced, but nitrogen is, okay, nitrogen is also balanced now, but lithium is not balanced, right? So it is 2 over here, and with chlorine also it's 2. So I will write 2 over here, and then these two will cut out, and I'll write 2, 2 over here. So I'm now 100% sure I have not made any error. You can also do it like that, that lead is lead is 1, nitrate is 2, nitrate is 2 over here, you should write over here too. But then again, it requires a lot of practice, and I would highly recommend that you do this method in order to be 100% sure that you are not making any mistake. Okay, then comes up writing up the ionic equation. Okay, so what do? You would cancel out the spectator ions. Okay, so what will happen is lead aqueous, lead solid, saved. Nitrate aqueous, nitrate aqueous, gone. Lithium aqueous, lithium aqueous, gone. Chloride aqueous, chloride solid, saved. Now I will only split up the compounds which are from which only one component is split up. It's cancelled. For example, this one over here. So from here I will get, this would be what? Pb2 positive. If you're not sure, you can take this over here, so it would be 2 positive over here. Got it? Okay, then over here we have 2 of chloride ions left over. Okay, and over here we have this one. This is already cancelled out completely, so we are not even going to look at it. Then we'll write over here Pb2 positive. In the aqueous state, we'll copy the state symbol as it is over here. Then we'll write the plus sign over here. We have 2 chloride ion. Why did we write 2 over here? Because in front of lithium chloride we wrote 2, right? So it implied over here. Then we wrote the arrow. We copied the state symbol over here. So this is aqueous. and then we copy this whole thing over here, lead that is lead chloride in the solid state. Okay, guys, that is it for today. Okay, if you have any query, you can always email me. All the best. Take care.